Okay, welcome back to Subject Science. This is 6.2 Optical Properties of Amphibole. In the last episode or in the last video, we have seen 6.1 the physical properties of amphibole minerals. Don't wait, please come with my channel, that is Subject Science. You will discover amphibole minerals are a complex category of silicate minerals. Okay, amphibole minerals it is a complex silicate structure that belongs to the ionophilic group and frequently found in igneous and metamorphic rock. The most abundant, the most occurrence of amphibole minerals are igneous and metamorphic rocks. They have a crystal habit that resembles ores that have a prismatic or needle-like structure. Okay, the habit or the crystal structure or the shapes of the amphibole minerals are prism or needle-like structure. Their chemical makeup determines their optical character, which are range from what calcium rich to magnesium rich types. Okay, so amphibole minerals are prismatic or needle-like shapes, and their composition is calcium magnesium. Okay, Tremolite and hornblende are a few examples of this group. Okay, the common groups of amphibole minerals are Tremolite, Actinolite, and hornblende. We have seen these minerals in physical property. Their optical properties are comparable through their color, pleochroism, and chemical compositional terms. Okay, Tremolite, Actinolite, and hornblende, most of the time they are similar, but their difference is due to their chemical composition. We have seen this based on their color, pleochroism, and chemical composition. Okay, the first one, that is hornblende. It is the most abundant amphibole mineral. It's called hornblende. Hornblende is a common amphibole mineral with a complex chemical composition, typically containing calcium, sodium, magnesium, iron, aluminum, and hydroxide ion. It has monoclinic crystal system and prismatic habit. So the common habit or the common characteristics of hornblende is it is a monoclinic crystal system and prismatic habit. We have seen it here. In microscope, hornblende seems like here. Okay, this one is in XPL, this one is in PPL, this one is in XPL. When it comes to in XPL, it is what gray green. Okay, have you seen this one? It's a gray green color. This is okay. And we have seen here. This is it have a perfect two sets of cleavage. Okay, amphibole mineral sits here in microscope. That's hornblende. It is optical property and vary based on its specific composition. Okay, yeah. But here are some general properties of hornblende. We have seen what are the common characteristics or the common properties or the common optical properties of hornblende. The first one is color. We have seen this one. Hornblende show a range of dark color. Here, have you seen? Including black, dark, green, we have seen here, brown. This specific coloration can vary based on impurity and the mineral composition. So the common color of the hornblende mineral color is seen in plain polarized light. Here, have you seen here? This one, this dark, okay, dark color. This one, and it is a cleavage. Here is this. Though the color is black, dark green, or bronze. The color depends on the impurity and the chemical composition. The second one is pleochroism. Hornblende commonly show pleochroism, meaning it displays different colors when viewed from different crystallographic direction. This property is particularly noticeable in tiny section specimen viewed under polarizing microscope. So, pleochroism, hornblende are pleochroism. That means there is a change in color when rotating the state. This this gray color of the amphibole mineral is changed when rotating the stage through 360 degree in plane polarized light. Okay. The other important optical properties of hornblende minerals are that is birefringence, meaning it has two different reflectance. This property can cause double reflectance intersection when under polarized microscope. Okay, the hornblende also it have a birefringence. The other is the refractive index. The refractive index of hornblende varies depending on its chemical composition, also its impurity, but generally within the range of approximate. So the approximate refractive index value for hornblende minerals are 1.6 to 1.8. So their refractance indexes depends on the impurity and the chemical makeups of the or the chemical structures of the hornblende minerals. Okay. The second and the most important amphibole group minerals are that is actinolite. Okay? It has a monocrystalline system that is similar to the hornblende and blooded shape. Okay? When we come to that of the hornblendes are a prismatic shape or that is needle-like shape, but these actinolites are or fibrous or radial. It is a mineral linked to the amphibole group, and it shares many optical properties with other natural minerals. Yes, we know. Here is a description of optical property specific to that of the actinolite. Okay, actinolite. When we come to that of hornblende, we have lost one property that have two sets of cleavage. Have you seen this one? Two sets of cleavage with 200. Two sets of cleavage have used this one with 160 degree to 100 degree cleavage direction. Okay, Amphiboles are hornblendes are two sets of cleavage. Okay. Actinolite we have seen here, like needle-like or bladder-like shape. Have you seen this one? This is the circle one. Well, when we have seen this one, we have seen this circular one, this shape, or with the color also that's gray white. We have one by one the color of the actinolite. It appears green, range from pale to dark green. We have seen this seems like green. Yeah, this. The color attribute to the presence of iron ion within the crystal structure. Okay, the color determine the presence of iron ions here. Have you seen? So the color of actinolite is dark green. Okay, range from pale to dark green. This one. Parts of actinolite is pleochroism. It commonly show pleochroism, meaning it displays different current when viewed from crystallographic direction. This property is particularly noticeable in thin section specimen viewed under polarized microscope. Okay, actinolites also show pleochroism like hornblende. This is simple when rotate the stage within 360. We have seen changing color. That color is called as pleochroism. The other important property is that reflectance. It is the reflectance index range approximately 1.6 up to 1.7 and affects how light is bent as it passes through the mineral and contributes to its optical appearance. Okay? Birefringence. It possesses two distinct refractive index, which is known as birefringence when examined under polarized microscope. These characteristics result in double reflectance, refraction, and thin section. Depending on elements like crystal orientation and mineral composition, birefringence have different strengths. Okay, we have seen. By the way, don't worry about this property. We have seen practical in laboratory about this optical and physical property. This actinolite show two cleavage directions that cross at right angle at roughly 56 up to 120 degree, like similar. This is a common characteristic of amphibole minerals. All amphibole minerals have around 56 up to 124 degree two sets of cleavage with cross with this angle. Okay, under microscope, this cleavage seen and it affects how the material looks from various perspectives. So actinolite also shows cleavage. The third and the last most common amphibole minerals is called tremolite. We have seen this one also in that of the physical property. So tremolite is another member of amphibole mineral group, sharing some optical property with other amphiboles like actinolite and hornblende. So tremolite and hornblende, they share similar optical property, but they are slightly different in color or other impurity or their crystal structures. So we have seen this one. We have seen this tremolite. We have seen here that is this shape. Have you seen? This is a tremolite in this section. Seems like here. This is in plane polarized layer, when this one is in XPL, or this one is in XPL. This is in PPL. Okay. It has a monoclinic crystal system that's similar to the others and unloaded, prismatic, and flattened. Okay? When we come in hornblende, it is prismatic and little like shapes, but we come to this one, it is prismatic, but it has flattened. Okay? This one. It is flattened or fibrisabit. Here a description of optical property specific to the tremolite. We have seen here below the specific property or the specific optical properties of tremolite. So this is the basic shape is prismatic and flattened. That from hornblende is prismatic here. Have you seen? Prismatic and flattened. We have seen one by one their optical properties. The first one is color. Tremolite appear in shades of white. You have seen this one. Please remember, color of mineral is determined in plane polarized light, not in XPL. Okay, here you have seen here the color of the mineral. This is white. Okay, have you seen this is white gray or pale green? The color variation is influenced by what? Impurity. We know the color is determined by its impurity and crystal structure, such as iron or magnesium, manganese. So due to the presence of impurity, the color of tremolite or other minerals is changed. So the common color in the common optical colors of the tremolite is white, gray, and pale green. The second one, the most important optical properties of tremolite is that's pleochroism. That is, it's also pleochroism besides that hornblende and actinolite. Tremolite can show weak to moderate pleochroism, displayed character, from different direction. When the stage of the microscope is rotate, the color of the mineral is changed. That color is called pleochroism. Now, refractive index. The refractive index of tremolite falls within the range of this one. This property affects the bending of light as it passes through the mineral and contributes to its optical appearance. Okay? The other one is birefringence. It passes two distinct refractive index, which is known as birefringence. When examined under polarized microscope, thin section may exhibit double refraction characteristics. Okay? A number of variables, including the orientation of the crystal and the makeup of minerals, can affect the amount of birefringence. So the cause for the amount of birefringence is orientation of the crystal and the makeup of the minerals can affect the birefringence of the tremolite or other minerals. Okay. The other and most important optical properties of tremolite is that is cleavage. Tremolite typically show two directions of cleavage, intersecting at approximately this angle. This cleavage can be observed under microscope and influence the appearance of the mineral when viewed from different angles. So generally, amphibole minerals have two sheets of cleavage that intersect at an angle 56 to 124, or some books say 60 up to 120. So this is a common characteristic of the Amphiboles minerals. Okay. Thank you more. Please like, share, and subscribe to my channel. In the next video or in the next episode, we will see pyroxene minerals. Okay.